Okay, so this is just a fraction review for any time we do fractions, but also to help you understand and remember how fractions work, because that's exactly the same things we need with this unit on rational numbers, because they're all fractions. They're just a lot more to it than just basic fractions. But this is just to help you remember how we do basic fractions. So let's just start with multiplying basic fractions. So if I have, let's say, 14 over 15 times 21 over 2, okay? So I'm trying to multiply this. Well, remember, it's very important to cross cancel. That means in an X, okay? It's exactly like reducing, except reducing. So let's do reducing. Let's say we've got 28 halves. Nope, don't want that one. Shoot, I should have come up with this before. Oh, something 18 fourths, okay? What can I divide into each of these numbers, the same number, evenly? Well, I can divide 2. So I divide 18 by 2 and I get 9. I divide 4 by 2 and I get 2. And so then my answer reduced is 9 halves. Okay? So let's come back and look at this that we're going to multiply. Cross-canceling is basically reducing only in an X instead of straight up and down. Okay? So what can I divide into both the 15 and the 21 evenly, the same number? Well, 3 can go into each of them. So 3 can go into 15 5 times, and 3 can go into 21 7 times. Now let's look and see what I can cross-cancel, the 2 and the 14. Well, 2 can go into each of those. 2 goes into itself once, and 2 goes into 14 7 times. Now, you notice when I cross it out, I always write the number that's left above or below. I find that this works so much better for students. If we put it out to the side or we don't put the ones, we mess things all up. Now, we just multiply the numerators across. So 7 times 7 is 49. And the denominators across, 5 times 1 is 5. Now let's just take a minute here. We got a couple of examples we can do here to talk about turning things into mixed numbers. Okay? In order to turn something into a mixed number, okay? So a mixed number. Okay? So I'm going to divide the 5 into 49. Well, 5 goes into 49 9 times. That's 45. Then I subtract, but there's nowhere else for me to go because I'm not going to do any decimals here. So that means this 4 that's left over becomes my new numerator, and my denominator always stays the same. So 49 fifths as a mixed number is 9 4 fifths. Okay? Now, I do not ever want you to to turn anything into a mixed number unless we are working with an applied problem, word problem, remember? Okay, so the reason being, as we get in higher and higher math, the improper fraction, and that's what this guy is, an improper fraction, 49 fifths, meaning the numerator is equal to or bigger than the denominator, makes it an improper fraction. Okay? We have 2 reasons why we want to leave it in improper fraction form. The first is it's easier to use. I know nobody believes that, but it really is. And the second is it's more accurate, okay? So imagine if we had 1/3. I know that's not a improper fraction, but it doesn't matter. That translates to 0.33333333333333. So if we had 3 of us using that number, and one person decided to make it 1/3, another person decided to make it 0.33333333, and another one decided to make it 0.3, do you think we would all get the same answer? We would not. If we all used 1/3, we would get the same answer. So we want to leave it in improper fraction form. It's different turning something into a mixed number than reducing. So I have 18/4, okay? I can reduce that to 9/2, or I can turn it into a mixed number of 4 and 1/2. That's a mixed number. This is just reduced. Turning it into a mixed number is not reducing it. So whatever you have always needs to be reduced, but leave it in improper fraction form, unless it's a word problem, and we can talk about that later. Let's talk about dividing fractions, okay? So if I have 3/4 divided by 21/22. Now, normally, or my guess is you guys are much more used to seeing it like this, okay? But in math that we'll be doing, we're going to be seeing it like this, okay? Now, we're going to do something called copy dot flip, okay? Copy dot flip. Either way, if we're doing it this way, we copy the first one exactly like it shows, dot, we change it to multiply, and flip, we flip the second one over, okay? Or if we're doing it over here like this guy, then copy, I copy the first one exactly like it is, dot, turn it into this division line becomes multiplication because we cannot divide fractions. We can only multiply them by what's the reciprocal, but we don't need to really know that. Copy, dot, and flip. So I flip this, and now we just do exactly what we just learned or we know about multiplying. So 3 can go into itself once and into 21 7 times. 4 can't go into 22, but 2 can go into each of these. So 2 goes into 4 twice, and 2 goes into that 11 times. So 1 times 11 is 11, and 2 times 7 is 14. And that's our answer. Okay? Now let's do adding and subtracting. Okay? So if our denominators are the same, then I just keep the denominator, and then I use my rules for adding or subtracting. Well, when I look at the -11 and the +5, that's an addition problem whose signs are different. So I subtract the small number from the big number. 11 minus 5 is 6, and keep the sign of the big number. And now I just need to reduce this. 6 goes into itself once and into 12 twice. And I'm done. If you didn't recognize that rules for adding and subtracting signed numbers, then please go to my video in the same section called integers and watch it. Okay, let's look at another one. -5 over 12 plus 9 over 16. Now, when the denominators are not the same, I have to get them to be the same. So I'm going to start multiplying things times 16. So 16 times 1 is 16. Does 12 go into 16 evenly? No. So then I need to keep going. And I always take the bigger one first. Always take the biggest one and do this. 16 times 2 equals 32. Does 12 go into 32 evenly? It does not, so I keep going. 16 times 3 is 48. Does 12 go into 48? Yes, it does. So my lowest common denominator here is going to be 48. Write it down there. Now I'm going to write this down exactly like it is, and I'm going to... What do I need to multiply with 12 to get 48? Well, that's 4. If I multiply 12 by 4, the denominator, I have to multiply the numerator by 4 as well. Okay? And now I'm going to write the other one down exactly like it is. And then I'm going to say, what do I need to multiply with 16 to get 48? Well, that's 3. And if I do it in the denominator, I have to do it in the numerator. Okay? So now my denominators are both 48, and I multiply these up, and now I just need to, this in the numerator is an addition problem whose signs are different, so I subtract the small number from the big number. 27 minus 20 is 7, and keep the sign of the big number, and we're done. And there, guys, is a quick review of fractions.